where we left off last week with section 2.7. We talked about inequalities a great deal before that, but we only had inequalities dealing with just, like x is less than this or x is greater than that. Today we're going to pick back up where we talked about absolute value in our inequalities. And I got the feeling from you guys that it was like right over the top of your heads last time we discussed it. So I'm going to try and take it a little slower today and make sure it's clear, crystal clear to you guys, exactly how you handle problems like what you see on your screen. Hold on one moment. There we go. Okay, so like the example that we looked at last week before we went on fall break was example 4 here. I gave you a couple of mnemonic devices as far as how to remember which word to use, right? We said if you've got the absolute value expression by itself, and you see less than or you see less than or equal to, that's an and statement. We're going to have a compound inequality where there's and. So at the very least, you need to have memorized what's in red on our screen. You guys have that written down in your notes? Okay, so we need to, at the very least, to have memorized what's in red. And then all of the same rules as far as like getting the x by itself apply just to the absolute value. So like if you have stuff going on, like if instead of just absolute value of x, if it was something like 5 times the absolute value of x, well, we would want to divide both sides by 5. Or if it was absolute value of x plus 2, we would want to subtract 2 from both sides. So all of those same rules apply as far as isolating the variable. We just want to start by isolating the absolute value expression. That's going to be step number 1. And then once we do that, that's when we assess what kind of compound inequality we're dealing with. That's when we're going to notice, okay, this is less than, so I'm going to use an and statement, okay, per our instructions over there on the right. So I was going to give this one to you guys to try on your own. Let's do this one together, though, okay? Let's do this one together. Write down this example. This will be example 5 here. And again, we're going to have 2 steps, okay, to start with, where we need to get the absolute value expression by itself. And I'm a big step-by-step guy, right? And so what I would recommend here is step 1, isolate the absolute value. That's step number 1, okay? Paul, tell me what 2 steps you want to do to, 2 operations you want to do to achieve that first step, to get that absolute value of x minus 1 by itself. What do I do to both sides?
Add 1.
All right, that's the very last thing I want to do. I definitely want to start the onion, outer layer.
Subtract 5.
Let's subtract 5 from both sides, all right? So I'm going to get 2 absolute value of x minus 1, and then less than 10. Continue. Again, absolute value does not, you can't distribute into absolute value like you would with parentheses. Peel back the layers, Paul. Get that 2 on the other side. What do I do to undo it times by 2? Divide both sides by 2. So we're going to divide both sides by 2. That's what we want. We want to isolate. Ooh, by the way, Alex, do I reverse the direction of the inequality when I divide by 2? Yes, no, or I don't know. You don't know? Somebody tell Alex when I would need to reverse. By the way, 10 divided by 2 is 5. Tiago, when would I need to reverse the direction of my inequality? If I'm dividing by a negative. So Paul said divide by 2. Therefore, we don't have to reverse the direction. Okay. So as we go through a problem like this, it's almost identical to how you would work a normal equation even. If your normal equation over here in orange was 2a plus 5 equals 15. Well, dadgummit, I would expect every single boy in here and at home to be able to say, oh, Coach Morgan, nothing could be simpler. Just subtract 5 divided by 2, right? So we all can solve for a over there in the orange, right? We can all get to a equals 10 and a equals 5. Well, that's all we're doing over here on the left in green. That's the same exact thing. Okay, you're just pretending like this is the variable that you're isolating. That's step number 1 of our process. We want to get the absolute value by itself. Okay, and nothing could be simpler than that. Now, once we achieve that step and we're keeping our head on straight, like what Alex and Tiago, what we were talking about with the direction of the inequality in that process, if we have that multiplication or division by negative, then of course we're going to remember our little caveat. The second step here, okay, is going to be of vital importance. I'm going to try and phrase it to where you guys can write it down verbatim, okay, word for word here, okay? So here's what I would recommend doing. All right, drop the absolute value bars. Rewrite the expression, or let's say inequality. All right, so we're going to drop the bars, rewrite the inequality once as is. Oh, space. All right, so when I do that, what that looks like over here, check this out. I'm gonna come over here and I'm gonna say, all right, I'm gonna rewrite this entire expression as is, just without the bars. Okay, it is as though you just pretend they're not even there. What would that look like? That would be x minus 1 is less than 5. That's pretty straightforward, right? What did I do? I just mentally erased those two absolute value bars. Okay. I'm going to pick the appropriate what do I mean by word? And versus or. Okay. So and versus or is what I mean there. So you tell me. Let's see here, Joey. Do you you know which word we should use here? Considering this is absolute value of x minus 1 is less than 5.
And.
Very good. It's less than, right? Did you hear what I emphasized there? If I've got absolute value of x minus 1 is less than, then I can now pick the appropriate word. Okay. And so I'm going to put an and in the middle. And then my third, or I guess fourth step in this case, my fourth step is going to be to rewrite same inequality with how can I'm having trouble thinking of how I could phrase this. I'll just say it verbally and you guys can write it down. So like when I dropped the bars the first time, I just rewrote it as is, right? The second time I'm going to rewrite it, I'm going to change two things, okay? I'm going to reverse the direction of the inequality. I'm going to change the sign of the other side. Rewrite the same inequality by reversing direction of the symbol and changing the sign of the other side. I know that's a little bit wordy. Sorry for that. But here's what it would look like. We're just going to have x minus 1 is greater than negative 5. Okay. Now, yesterday, last week, last Tuesday, I gave you a visualization as to why the heck we were doing that. Okay. And I'll do the same thing here. Here's your visualization for why we just did what we did. Okay. This right here translates pretty much to, hey, 1 is some number that is 5 spots away from 0. That is less than 5 spots away from 0. So what we're saying is we're saying that it would either be here or here, right? We're saying that if its distance is less than 5, I kind of think of it, I think I give the example of, hey, put out an APB, let's make a 5-block perimeter or whatever, you know. What we're saying is that x minus 1 lives within 5 units of 0 to the left and to the right. That means that it's going to be greater than negative 5. Check what I just put a check under there. X minus 1 would be greater than, in other words, to the right of negative 5, or excuse me, and it's going to be to the left of positive 5. In other words, it's going to be between these two values right there. X minus 1 would live somewhere between those two values. That's exactly what this statement right here that I'm circling in blue means. It means that x minus 1 is between negative 5 and positive 5. Okay? Now what we can do is we can just go through and solve both of these final ones just by adding 1, right? So what would we get? X is less than 6, and X is greater than -4. And we want to be smart about it. We want to put that together, okay? So we want to put that together as X is going to be between -4 and 6. That's a smart way of drawing that out. If we were going to put that on a number line, obviously we'd have -4 and we'd have 6, open marks on both sides and shading in between, or we'd have parentheses -4, 6 if we were using interval notation. So there's our 3 ways, again, of writing out a solution to that inequality. And how can I check to make sure that it's a good solution? What do I always look for? What do you think, Mossy? How do I know that, like for instance, Mossy, pick me a number between -4 and 6. 2. What should I be able to do with the number 2? Granted that that's in my solution set. What do you think, Charlie? Plug it into the what? The original inequality. I ought to be able to plug it in right back up there. Okay, so Mossy picked the number 2. Let's test him out. All right, so 2 is let's just say there's the number 2. Okay, that means that I should be able to get a true statement. So 2 minus 1 plus 5, and we want to say, is that less than 15? All right, well, you do the arithmetic. 2 minus 1 is 1. Absolute value of that is 1 times 2 is 2. What's 2 plus 5? Which is less than 15. Ding, 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 ding. Winner, winner, chicken dinner. Okay, let's pick a number. Okay, Mossy picked 2. Pick a number for me, Quentin, that's not in my solution set, that would be outside of our little interval. 10. So like the number 10 will be like way over here. So if I plug that in, what should I get? A false statement. I ought to get a false statement, big fat false, okay? So check this out. Let's do this, except instead of 2, let's plug in 10. All right. Y'all help me out. 10 minus 1 is? 9. Absolute value of that is? 9. Times 2 is? 18. Plus 5 is? 23 is, last time I checked, not less than 15. Okay. So interestingly enough, we can pick numbers that are inside our interval. We can pick numbers that are outside of our interval. You could even be clever and pick the number 6, right? 6 minus 1 is 5 times 2 is 10 plus 5 is 15. Is 15 less than 15? No. That's why we didn't include that endpoint. Neither endpoint would be included in our solution set there. Okay. But look, it's going to take a little bit of practice. It's kind of awkward. It's kind of weird to be solved. Let's look at another one. I'll give you another couple of practice problems today. Okay, so here's example 6. First thing I want to do, Lewis, is what?
Is isolate the absolute value.
Very good. So to do that, we want to do what to both sides?
Divide by 4.
Fabulous. So I got absolute value of x minus 3 greater than or equal to 1/2. Notice I did not switch the direction of my inequality because I did not divide by a negative. All right, fabulous, fabulous. Okay. Now, here's where we rewrite it once without the bars, just as is. Then we want to pick the appropriate word. This time my word is going to be what? Or, because it's greater than or equal to. So I'm going to put an or there. And the next time I'm going to rewrite it as is, except I'm going to reverse the direction and change the sign. All right. And bam, we just did all 4 of those steps that I typed in rather awkwardly in the previous example. Okay, so Lewis helped me do step number 1. He said isolate the absolute value. And then I dropped the bars, rewrote it once. Dropped the bars, rewrote it again, just switched the direction of the inequality, changed the sign on the other side, and we picked the appropriate word based on our little mnemonic device. Okay, now all I have to do is add 3 to both sides. So I got x greater than or equal to 3.5, or what is that, 7/2? I like improper fractions. And then add 3, so 3 minus half is 2.5, so it'll be 5/2. Less than or equal to 5/2. Okay, let's see what that would look like graphed out. What do you think? I'll put that up here. So obviously 5/2 is less than 7/2. So I want to put 5/2 on the left. Here's all right. They're going to be close marks, aren't they? Now, less than or equal to 5 halves would be shading to the left. Greater than or equal to 7 halves would be shading to the right. Now, what that looks like is where we don't have an overlap, right? We don't have an overlap, but that's okay. It was an or statement. What's the key phrase for an or statement that we're looking for? At least one is true. Okay, good. So when I pick a value like, I don't know, pick me a number Alex, pick me a number that's greater than 7 halves. What'd you say, Alex? It sounded as though Quentin said something. I know Quentin wouldn't have said something when I called on you, Alex. Oh, was that Alex? Oh, dadgummit. Okay, I got more than one Alex. I was looking at Alex Went on the computer, and Alex Cano said something in person, so never mind. Sorry, Quentin, I was trying to bust your chops. Chops adequately not busted. Alex Went, pick me a number greater than 7 halves. Quickly, quick, come on. Alex Went, such a disappointment. You know what I need when I'm disappointed? What do you think I need, Mr. Jacobs? Birthday cake would be nice. How about a good story? I'll tell you guys a good story real quick. That perks me up. In the meantime, Alex, if you could kindly type me a number, since apparently your microphone is not working, type me a number that's greater than 7 halves. I won a prize this morning on my way to work. Can you believe that, Tiago? I won a prize. How did I win that prize? I called into the radio. Look, one of my favorite things to do in this life is to call into the radio and win things. And so Kix 106 had a big hairy question this morning, and I was the big hairy question champion. I won a prize. I got a gift card to Malco movie theaters, so I can go see a movie now. Nothing can stop me. Baloney, it's kind of useless. I went to see a movie 2 or 3 weeks ago and enjoyed it thoroughly.
Aren't they just playing old movies?
No, I want to see the new Christopher Nolan movie, Tenet. It was a mind blower, by the way. Fabulous movie. All right, so Alex Went has said 8 halves, which is equivalent to 4. So if I plugged in 4, thank you, Alex. If I plugged in 4, look what I would get. 4 minus 3 is 1. Absolute value of 1 is 1. Times 4 is 4. 4 is greater than or equal to 2 last time I checked, so that worked out. Now, he picked a value over here, and although that was to the right, it made a true statement in shaded regions. It didn't make a true statement in both, but that's okay because it's an or. I wasn't looking for an overlap. And again, remember what absolute value means. It means distance from 0. So what that I've just circled in orange means, okay, is that x minus 3 is some number that lives at least a half a unit away from 0. So if we were going to graph out that, it would be here's 0, here's a half to the right, and here's a half to the left. And what we're saying is that x minus 3 is somewhere to the right of 1/2 or somewhere to the left of negative 1/2. Fellas, I mean, that's exactly what we just wrote up. Look, right here. X minus 3 is greater than or equal to 1/2. Look at what I just boxed in there in red. That's precisely half of the setup. And because they're pointing in opposite directions, that's the other part of the setup was where x minus 3 would be less than or equal to negative 1/2. And again, that's exactly what we have. Oops, I'm trying to color code it for you. That's exactly what we have right there. Okay, so when we follow our steps, that's what we're doing. We're accounting for both scenarios. Earlier, it was, okay, the first scenario was, hey, our expression needs to be greater than negative 5, and it needs to be less than positive 5. Well, that's what we had here. Greater than negative 5 and less than positive 5. All right, I'll give you guys one to try. You guys do this one on your own. You've had 2 from me. Let me see if I can get you to do one here, and I'll give you a couple minutes to work. Yeah, the big hairy question today was, they surveyed a bunch of people about their favorite thing about fall, and the number one thing about fall was favorite thing about fall was the changing of the leaves, and the question was, what's the number two favorite thing about fall? And so I said cooler weather, and that was it. A big hairy champion question, I am indeed.
Do we just have to put it on the number line?
I would like it on the number line, and I would also like interval notation. Now, if you get stumped on the interval notation, that's okay, because this one's going to be an or statement. But I am kind of curious to see what you guys would think about it. So I'll give you about another 60 seconds, and then we'll reconvene. Now, I already, by the way, did for you on this one. So really, you're just rewriting it twice, picking the appropriate word, graphing it out, and also trying to do some interval notation for me. All right, all right, all right. So let's see here. I'm trying to see if I don't think I talked to Nate yet. Nate, what word should I pick? Earth to Nate. Nate Dog, what word should I pick? You people and your busted mics. All right, Jack McBee, I know you can talk. What word should I pick?
Or.
Yeah, very good. So it's greater. So I know it's going to be or. Let's see where my O goes. There we go. I know it's going to be or. So I'm going to have 3x minus 1 is greater than 7. Or what? What do you think, Drew?
3x is less than negative 7.
Oh, Jack took care of it for you, Drew. 3x minus 1 is less than negative 7. Precisely. Very good. All right, so we'll throw it your way, Benton, for my 2 steps to get x by itself. What do I do to both of those? Speak up. Add 1 to both sides. So I got 3x greater than 8. I got 3x less than negative 6. Continue. Continue. What do you do next? Divide by 3. Very good. That'a boy. So divide by 3. We got 8/3. Don't forget we got an or. And then we've got negative 6 divided by 3. Negative 2. All right. So if I'm going to graph this one out, ors, remember, oftentimes are pointing in opposite directions. Okay. So on my number line, I just got to make sure I square it up. 8/3 is the one that's going to be on the right. -2 numerically comes on the left. We know that. Less than -2, open mark and shade to the left. Greater than 8/3, open mark, shade to the right. Is that okay that I didn't have a crossover or an overlap? Of course it is, because I'm not looking for both to be true. I'm looking for, what's the two words? At least one to be true. So for example, I could pick a number like, oh, I don't know, the number 11. I could plug in 11 and I should get a true statement. But if I plugged in something like the number, like if I plugged in the number 0, I would get a false statement. 0 times 3 is 0 minus 1 is -1, absolute value, which is 1. 1 ain't greater than 7. So a good way to do this, fellas, is to just visually pick a couple of test points real quick to verify. And then this is the interesting part that I was shooting for. Here's how you would do interval notation. Are you ready for this? Okay. We're going to have two intervals. First of all, we're going to have from -infinity to -2. We're also going to have from 8/3 to positive infinity. And what symbol do you think goes in the middle? Think back to your Venn diagram. Did you take notes on our Venn diagram the other day? Charlie's looking back. That a boy, Chuck. What symbol did we say? We're not looking for the intersection. We're not looking for the and. This one's an or. What was the symbol that we used? Look back in your notes. Don't be lame. Don't be lazy. What does it look like? It's a U. Very good. So, Paul, if you're not there, you can always watch the class recording, son. Not an excuse. All right. So the union of those two. I'll show you what I mean. I'm going to teach this to my 9th graders today. Let's see here. 2.6, wasn't it? 2.6. So this was when we had. Yep, there we go. There we go. Y'all should hopefully remember this page where we talked about the intersection being the and statement. Like if a student takes algebra from me and plays baseball, he would be in the middle. That's that little hump. That's the intersection symbol, right? And then if a student does at least one, he's in the union. That's the or. Like if you said, yeah, I take algebra or I play baseball, as long as you do at least one of those, then you're straight. You could do both. Right? But we said you could do algebra only, you could do baseball only, or you could do both. That's called the union. And that's how we would symbolize when we have two disjoint intervals. That's how we would symbolize both of them at the same time. Where are we? Where are we? Where are we? Yeah, boom, right there. Okay. So because I can't do both of them, that's okay. I can still say here's the left chunk or here's the right chunk. And now look, y'all are 8th graders, okay? This is a little bit above your pay scale, so to speak, right now. This type of interval notation that we just discussed, that's more, kind of some algebra 2, getting into pre-calculus kind of notation. So I'm not expecting you to be masters of that kind of thing. I do expect you to be able to graph it out on on a number line, though. Y'all feel more comfy doing that, I hope, okay? Like open mark and to the left, closed mark, when we figure out how to graph on a number line, that's more in line with our Algebra 1 kind of curriculum. But I do like to push you guys a little bit. I do want to give you guys an opportunity to be ahead of the game when you get into some of those classes, like calculus or pre-calculus or whatever, to where you've already, Quentin rolls up in there, he's like, this interval notation, I'm a pro at this already, I've had it. Okay, so here's some homework for you this week. You might have noticed that on our actually I don't have to do it this way. Let me see if I can pull it up here. On our Teams channel, I had a notification that went off this morning. That is because y'all have an assignment through Microsoft Teams. So those of you that are able to log in using your CVHS username and password, like I gave you, you'll notice this thing's moving slowly. But on our general channel is the ACT practice quiz number, what are we up to, number 8? Yeah, right there. That posted yesterday morning at 8. It's due Friday morning at 8. Why don't y'all give it a shot, see how you do, okay? And what I will do in the meantime is I'm prepped and ready to get you guys on into chapter 3 now. So you'll be ready to rock and roll with some new material coming in, not tomorrow, but on Thursday. So I'll see you guys virtually on Thursday, and then I'll see you guys that are at home I'll see y'all in person on Thursday. All right. Thanks for a great class. If you have any questions, holler at me. And in the meantime, live Jesus in our hearts. Excellent. Thank you, guys.